So the first fundamental concept in calculus is known as the limit. And I'll explain the limit by first using a simple function f of x equals x squared. So x squared is just a parabola. So it would look something like this. Okay, now I can say that if x equals 3, then y equals 9. That is reasonable. I can also express this by just saying f of 3 equals 9. So these are essentially the same thing. So let me make another fairly reasonable observation. I'm going to say that I noticed that as x approaches 3, y approaches 9. So I'm saying that this is happening at the same time as this. But what does this actually mean? Well, if you think about what it means to approach something and how you would define that term in real life, all you are saying is, I am continuously moving towards that location. I'm continuously getting closer and closer to it. But that does not necessarily mean I am at that position. If I wanted to say that, I would just simply say, I am at this position. But no, instead I'm saying I am approaching it. I have not reached it yet. I'm simply getting closer and closer to it as time passes. So this is the same thing in math. Equals, if I wanted to say I'm at somewhere, I would just say x equals 3. If I'm at 3, x equals 3. If I wanted to say I'm getting closer and closer to 3, I would say I'm approaching 3. So this is what it would look like if you wanted to use some values on a graph. So you could say, okay, I want to pick x values that get closer and closer to 3. So I could say we can use 2, and the next value would have to be closer than to 3. So I could pick 2.5. That is closer. I could do 2.9, 2.99, 2.999, 2.9999. So this is essentially illustrating this right here. My x values are getting closer and closer to 3. And I could keep going. I could write 100 more x values. 2.99999, 2.9999999. I could keep going, and it's all following the same concept. I'm getting closer to 3. So this could never end, really. But what I'm really saying here is, as this is happening, as these numbers are getting closer to 3, simultaneously y is getting closer to 9. So how can I illustrate this? Well, I have a chart here. So maybe if I just plot out these resulting outputs and I observe what these numbers are headed towards, the behavior of these numbers, maybe I could observe what y approaches as x approaches 3. So we can see, okay, if y is 4, or if x is 2, then y is 4. If x is 2.5, y is 6.25. If x is 2.9, it turns out y would be 8.41. If x is 2.99, y would be 8.9401. 2.999 gives 8.99401. And finally, 2.9999 gives 8.9994001. Okay, I could pick more x values that get closer to 3, but judging by the way these numbers are going, I could probably assume that the outputs, or y, would be 8.99999, something like that, right? Because these numbers appear to have that pattern. But what are the y values approaching? Well, if you look at this, 8.4, 8.9, 8.99, 8.999, it seems to be getting very, very close to 9, right? So this statement must be true. But wait, this was only approaching x, or approaching 3. X was only approaching 3 in one direction. If you want to zoom in and say maybe about, if you want to zoom in here, I just said as x approaches 3, using these values, so maybe 2 is like somewhere over here. As these numbers are getting closer and closer to 3, y is getting closer and closer to 9, which is following this curve, basically, right? But this was only from one direction. What about the other direction? Well, I would have to figure out what is happening here as well, because x can also approach 3 in the opposite direction. So it would look like this. Okay, so maybe I want to approach 3 in the other direction. So maybe I would choose a number like 4. And I could say, okay, I need to approach 3. Well, 3.5 gets closer to 3. 3.1. 3.01. 3.001. 3.0001. So these numbers, they're doing the same thing as these numbers. They're both, these x values, they're both approaching 3, which illustrates this idea right here. So now, if I wanted to graph the resulting outputs, let's see what the behavior of the y values are. So if x is 4, y is just 16. And if x is 3.5, y is 12.25. And if x is 3.1, we would get 9.61. Okay, so right now it's not clear what y is approaching, but we have more values, so we'll keep going. 3.01 gives 9.0601. Okay, 3.001, it gives 9.000 or 006001. Okay, so it's getting a little bit clearer now, but we can do another value to make sure. So 3.0001 gives 9, or 3.001. Okay, 9.00060001. Okay, so now, as the x values are approaching 3, getting very, very, very close to 3, what is y doing? Well, we can see 9.6, 9.06, 9.006, 9.0006 about. It's getting very, very close to 9, right? It's almost exactly 9. The error is so small. It's almost indistinguishable. So, because from both directions, where when we say x approaches 3, this would mean the x values are approaching 3 from the left, and then they're also approaching 3 from the right. Maybe 4 is around here, right? 3.5, 3.1, 3.01, 3.001, and it's getting very, very close. And at the same time as this is happening, the y values are at, around 9.6, something like that, and it's going very, very close. And all these numbers are doing is they're just following the curve. So what's special about this is I could keep zooming in. And when I do keep zooming in, all I'm doing is, if I wanted to illustrate this using a chart, is plugging in numbers that are even longer, 2.999999, 3.000001. And the resulting outputs would be very, very close to 9. They would probably be 8.999999, something like that, or 9.000006, around that range, right? So this is essentially what a limit means. You are, as an x value is approaching some number, what is happening to y? What is y approaching? So all you're doing is following the curve. So in this case, this is a number that y approaches. So this can actually be expressed using mathematical notation. This is just the same thing as the limit as x approaches 3 of f of x equals 9. Or, in this case, f of x, the function is just x squared. So these are saying the same thing. As x gets closer and closer to 3, here and here and here, what is happening is simultaneously 9, or a y, is getting closer and closer to 9. So here, here, you can see it here, and here, right? So you might ask, well, this right here and this right here, they kind of look similar in a way. This output of 3 gives an input of 9. When x equals 3 here, the y equals 9. So are they the same thing? Well, no. That would be just in this particular case, they're the same thing. So here's an example where they may not necessarily be the same thing. Okay, so let's say I have a function now, and it's 1/2 x. But there's a special condition. The condition is that x cannot equal 10. And I wanted to graph this. So it would end up looking something like this, right? A straight line. But at this point right here, at this coordinate 10, 5, you actually can't draw a dot here. Why? Because the function is undefined at that point. So when we have a function that is undefined at a point, for example here, where, if you want to say f of 10, the answer would be undefined. There is no value. So here, instead of drawing a dot, what we do is we just draw an open circle. This represents that there is no value here. So if I wanted to say, okay, what is f of 10? It's undefined. There's no number. There's no output. You cannot use this input. But now, what if I wanted to ask, what is the limit as x approaches 10 for this function f of x equal to? Okay, so I want to use the same logic as before. What is happening as I am getting closer and closer to this point from the x direction? So in this direction and in this direction. So something like this. So as I'm approaching x from this direction and this direction, the number 10, what is happening to y? Well, for here, from this direction, from the left, when I'm going this way, so from here to here, right? I'm going this way. What is happening to y? Well, the y value appears to be increasing, right? If we follow this line. What about this way? Well, it appears to be decreasing. And it makes sense. When y is increasing, y is increasing. When x is decreasing, y is decreasing. Just like how the function says it should be. It has a slope of 1/2. So as x is getting closer and closer to 10, y, we know it's increasing, but what number is it getting closer and closer to? So we can use that chart again to help understand the intuition behind the limit. So once again, we're saying, okay, I need to pick values of x that get closer and closer to 10. So we could do 9, 9.9, 9.99, 9.999. Y would be 4.5. 9.9 for this function, it would give us 4.95. 9.99 would give us 4.995. 9.999 would give us 4.9995. And remember, I can keep doing numbers. Keep putting in values of x that get closer and closer to 10. But what will happen is the outputs, the y values, they will get closer and closer to, it seems to be 5. So I can say that this answer must be 5. Why? Because this is going to 10. This is 4.9, 4.99, 4.999. It's very, very close to 5. And we can observe it here in this graph too. If we keep zooming in, and we zoom in forever, maybe we'll end up at a coordinate like 9.999999 on this line, right? Then the resulting y would be 4.999999 something. So we know that we can, if we keep repeating this process over and over, y is getting closer and closer to 5. But remember, it does not necessarily equal 5, because in this case, y cannot equal 5 actually. It's undefined at that point. So if I wanted to write the limit in a general sense, I would just write the limit as x approaches c for some function f of x equals L. So remember, this is the exact same thing as saying as x gets closer and closer to c, y gets closer and closer to L. They're the same thing. And this process of getting closer and closer to c, you can keep using x values that get closer and closer to c. This process will never actually end. All you are saying is that you're trying to describe the behavior of the function. So for any arbitrary function, f of x, this limit, this idea of a limit, is really explaining the behavior. So it's not like the input and output where you have an input of c, well in this case it seems to be L, right? There's an intersection right here. This is just saying you input c, you have an output of L. This is not saying that you input c and you get an output of L. This is saying, okay, x is getting very, very, very close to c, right? From both directions, from the negative and the positive. What is happening to y as you follow this curve? Well, y appears to be approaching L. So it has nothing to do with what is actually at the point CL, right? The coordinate CL. It has nothing to do with what's right there. It could be an open hole. It does not matter. All we're trying to do is describing the behavior of the function using the limit.